Welcome to this explainer. We usually look up at the night sky and think, wow, so peaceful, right? Well, scratch that. Today, we're taking a visceral, eye-opening tour through the universe's absolute most hostile environments. We're going to uncover the extreme cosmic realities hiding out there in the dark. Trust me, the cosmos is packed with absolute horrors.
Let's kick off our journey about 64 light-years away, looking at a planet called HD 189733b. From afar, it looks peacefully beautiful, doesn't it? With that deep, rich blue color, you might almost mistake it for a massive, tranquil Earth. But man, looks can be deceiving. This serene appearance is actually hiding a violent cosmic nightmare. The contrast here is just staggering. The horrifying reality? That beautiful blue marvel is being ripped apart by 5,000-mile-per-hour winds. And that gorgeous blue color? Yeah, that's not water. The atmosphere is literally choked with tiny particles of silicate glass. So those 5,000-mile-per-hour winds are whipping that glass through the air like a relentless storm of sharp blades. And it doesn't rain gently downward. It rains sideways. All of this in temperatures that would melt metal almost instantly. No thanks. To make sense of all these chaotic extremes, today's tour map is going to guide us through 4 distinct categories. First, scorched and melting worlds. Then, dark and frozen wastelands. Next, crushing storms and pressure. And finally, the radioactive graveyard.
Section 1, Scorched and Melting Worlds, the universe's ovens. And we don't even have to look very far to find our first nightmare. We're actually starting right here in our own solar system. This brings up a huge misconception. It's supernatural to think Mercury is the hottest planet, right? I mean, it's sitting right next to the sun. But Venus? Venus is our true evil twin. Even though it's further away, it's got these incredibly thick carbon dioxide clouds that trap heat so perfectly that the surface is actually hotter than Mercury. We're talking melting temperatures and crushing atmospheric pressure that is 90 times stronger than what we feel on Earth. To put that into perspective, the Soviet space probes that actually landed there, they survived only a tiny fraction of time before totally failing under the extreme heat and pressure. All of this is happening under a sky thick with toxic sulfuric acid clouds, where sunlight barely even reaches the ground.
Now, if we zoom way out of our solar system, we stumble upon some truly bizarre hot worlds. First up is WASP-12b. This is a distant gas giant orbiting so close to its star that its physical body is being stretched apart by gravity. It literally isn't even a sphere anymore. It's stretched out into an egg shape. It's boiling at over 4,000 degrees Fahrenheit, and, get this, it is slowly being consumed piece by its own host star. Then we have 55 Cancri e. This is a tidally locked super-Earth. Because it's tidally locked, the exact same side always faces its star. So that day side is permanently roasting at over 4,000 degrees, complete with a super thick, hostile atmosphere and massive glowing rivers of flowing lava.
But to really understand the absolute king of heat, we first need to quickly define what a subdwarf star is. Basically, it's a type of dying star that is extremely small but burns fiercely and intensely hot.
And that brings us to the rocky planet Kepler-70b, which has the absolute misfortune of orbiting one of these subdwarfs. The crucial takeaway here is the number, 13,000 degrees Fahrenheit. Kepler-70b sits so dangerously close to its dying star that a whole year, its entire orbit, takes just a few hours. Because of that, the surface reaches an unimaginable 13,000 degrees, which is actually hotter than a lot of stars. At that temperature, rocks can't even stay solid. The planet is basically covered in flowing oceans of molten minerals and literally vaporized stone, just getting constantly bombarded by radiation.
Section 2, Dark and Frozen Wastelands, the Cosmic Void. All right, let's step out of the fire and head into the absolute, terrifying isolation of the cosmos. Less than 1%. The planet TRES-2b reflects less than 1% of the light that hits it. That makes it the darkest planet we have ever discovered. It is literally darker than almost anything we know of on Earth. Scientists actually think its atmosphere is filled with chemicals that just eat up all visible light. But here's the wild part. Despite being wrapped in complete, absolute darkness, it's still incredibly hot. If you could safely stand near it, which you can't, obviously, it would just look like this faint, hot red glow trapped in an endless pitch-black void. Then we have this wonderfully frozen world. Just take a second to absorb that impossibly long alphanumeric soup of a name. OGLE-2005 BLG-390LB. I mean, come on, that definitely deserves its own spot in the Guinness Book of World Records just for the name alone. But record-breaking name aside, the reality of this place is just intensely grim. It's a completely hostile, frozen wasteland sitting so far away from its parent star. We're talking temperatures plummeting below minus 300 degrees Fahrenheit. The surface is nothing but endless ice and rock trapped in permanent darkness. Now, fascinatingly enough, some scientists suspect that beneath all that frozen crust, there might actually be deep underground oceans warmed just a tiny bit by the planet's internal heat. But make absolutely no mistake, this is completely unlike anything humans could ever survive on. Moving right along to Section 3, crushing storms and pressure, violent kinetic energy. Leaving the quiet freeze behind, our tour enters worlds totally defined by violent kinetic energy and crushing atmospheric pressures. Let's take a closer look at what would actually happen if you try to descend into our massive neighbor, Jupiter. You see, Jupiter doesn't have a solid surface like Earth. Instead, you just plummet through endless layers of storms. That includes the Great Red Spot, a storm literally larger than Earth itself that has been raging for centuries. As you sink deeper and deeper, the atmospheric pressure rises to absolutely unimaginable levels. Eventually, the pressure gets so intense that hydrogen gas gets squeezed and transforms into oceans of liquid metallic hydrogen. That creates these incredibly powerful magnetic fields, teeming with deadly radiation that would instantly fry any spacecraft we could build. And then there's Saturn. The Lord of the Rings might look incredibly calm and majestic when you peer through a telescope, but the reality is a completely different story. Beneath that peaceful appearance are freezing cloud tops and massive storms driven by insane wind speeds. Just like Jupiter, there's that crushing pressure deep inside the gas giant. But Saturn takes it a step further with bizarre phenomena like rain made entirely of liquid helium. And the terror doesn't stop at the planet. It extends out to its moon system too. Places like Titan and Enceladus are wild worlds all on their own, featuring literal lakes of liquid methane and violent icy eruptions. Even further out is Neptune, the most distant major planet in our solar system. Because it's so far away, it gets very little sunlight, so it's freezing and pitch dark. But do not let that fool you into thinking it's quiet. It is incredibly violent. The storm systems here are some of the fastest we've ever recorded, whipping across the dark atmosphere at over 2,000 kilometers per hour. And if you somehow manage to go deep below those dark clouds under all that crushing pressure, scientists believed you'd run into totally exotic, strange forms of ice and superheated water existing at the exact same time. It's mind-bending. Finally, Section 4, the radioactive graveyard, afterlife of dead stars. For our last stop today, we are leaving traditional living planetary systems behind entirely and entering the chilling, radioactive graveyards of the cosmos. To really grasp the horrors waiting for us here, we first need to define what a pulsar is. When a massive star dies in a huge explosion, it sometimes leaves behind a tiny, collapsed core. That dense, rapidly spinning core is a pulsar. It is violently active, constantly blasting intense radiation and incredibly powerful beams of energy straight out into the void of space. Now, just imagine being a planet stuck in that kind of environment. The incredibly named planet PSR B1257 plus 12b likely formed from the leftover debris after its original star exploded in a supernova. So it survived the literal death of its star, but its prize for surviving? It now has to orbit right beside one of those dead, violently spinning pulsar cores. That means it's constantly, relentlessly exposed to those intense energy beams. It's bathed day and night in deadly levels of radiation that would absolutely obliterate life as we know it. So after stepping through the universe's ultimate house of horrors, what's the big takeaway here? What does all this melting, freezing, crushing, and radioactive madness actually mean for us? Well, I think this quote hits the nail on the head. Looking at these cosmic horrors highlights the miraculous, delicate balance of our own planet. Honestly, witnessing the sheer, terrifying hostility of the universe out there shouldn't just scare us. It should leave us all with a profound, awe-inspiring appreciation for the fragile, hospitable sanctuary we're incredibly lucky to have right here. So I want to leave you with this question. With a universe filled with such violently extreme and terrifying conditions, just how incredibly lucky are we to call Earth home? Think about that the next time you step outside and feel a gentle, completely non-lethal breeze. Thank you so much for joining me on this explainer, and keep looking up.